Hello, everyone. For our senior design from the MSET department representing Go-Kart, my name is Amir Mansuri.
I'm Chunky Park.
I'm Stephen Gabriel.
And my name is Emmanuel Acevedo. So go-kart is a simple four-wheeled, small-engine, single-seater racing car. The first go-kart was built by Art Engels in Southern California in 1956 while working for the Curtis Craft Company. With the help of his neighbor Lou Borelli, they worked on a small one-man racing vehicle that anyone could drive. They selected a West Bend 2.5 horsepower engine with a small prototype frame. When their invention finally worked, they showed it off at the Pasadena Rose Bowl and it became very popular. The go-kart is usually used as a low-cost and relatively safe way to introduce drivers to motor racing. So these are some of the current go-karts that are available now. So go-karts have come a long way since Art Engels' go-kart in 1956. Most go-kart manufacturers have chosen electric motors for their immediate throttle response. And usually gas-powered vehicles consist of a four-stroke OHV engine, and electric go-karts prefer an electric brushless DC motor. These are just some of the specs of pole position raceway go-karts. So these are some similar go-karts from the ones that we're making. The first one is Fit Right 2020 Baja X with a top speed of 20 miles per hour. And the cost of this go-kart in the market is $949.99. These are the specs. The second one is a Segway 9-bot, which goes 13.5 miles per hour at $799.99. And the last one, a Mototech Mud Monster with a top speed of 20 miles per hour at $990.
The objective for our project was to build a go-kart which can run between 25 to 30 miles per hour, which is safe to drive. We want to make sure that we could fit a 6 feet tall and 250-pound person into this go-kart. In this go-kart, we also install headlights, which is powered by solar panels. And
So our initial design at the beginning of the year was to make an all-electric go-kart. So the components were electric brushless DC motor, specifically the best equipped 3000 watt brushless DC motor, a controller, a chain, brake and pedal system, and for the power supply, we would use 512-volt batteries connected in series. The go.
So we thought it would be great to implement solar technology on our project because it has many benefits. So it provides renewable and sustainable energy, and it has long lifespan over 30 years, and obviously it has zero emissions. So we researched how the solar panel works to use it properly. So solar panel is made of crystalline structure of silicon, and monocrystalline solar panel has a higher efficiency. And when the photons from the sun hit the solar cell, electric field is generated, and it makes the electrons only go one way. And these electrons are collected by thin metal fingers at the top of the solar panel. So we were considering how to connect a solar panel to our go-kart, and we realized that there are different ways to use solar panels. And PWM and MPPT are the solar controller, which can improve the solar energy conversion. And MPPT controller has a 30% higher efficiency. So 100 watt typical solar panel generate 8.33 amps hours. So these are the initial designs of our solar system. in our project. So figure 1 was our first design, which consists of 200-watt solar panels with a PWM controller, and it can fully charge a 50 amp hour battery in 3 hours. But we realized that we did not have enough room to place 2 solar panels on our go-kart. So figure 2 was our next design, which consists of a 100 watts solar panel with an MPPT controller. But we had to change our plan because our budget was not enough to afford our initial design, but we still wanted to use solar technology. So we decided to use a different solar panel. So we tried to research other solar panels, and the first solar panel is the portable solar panel, and it's complete overcharge protection, but it's actually expensive and heavy. The second one we found was the mini solar panel kit, and it's easier to handle and manage them, but they do not generate enough power for our headlight. So the last one is the small solar panel we decided to use, and it has lightweight, good efficiency, and has a great circuit protection, and it is also waterproof.
A go-kart chassis. For this go-kart, it was built with ASI 1018 steel alloy. We bought this go-kart. It was broken from a Craigslist. We bought it for about $70. As you can see here in this video, this was the first video, and the go-kart was broken, and also some axle was like bended and all that. We also used the stick welding to weld some other places because that was also broken. We used a hardwood base to build the seat. We used some sofa cushion on top and put a leather seat to cover it. Engine and rear axle. We use Breed's engine, which are typically used for lawnmowers, pressure washer, and electrical generators. For this product, we use 212cc with 6.5 horsepower, which was about $110. We also had to do the break-in process. We bought the new engine. Also, we use a 3/4 clutch with the number 35 chain, which is connected to the rear axle. And yeah. For our goal, we wanted to reach 29 miles per hour, but we wanted to make sure we do some calculation before we buy any parts. Here are some calculations based on the axle on the teeth, the clutch teeth, and the diameter of the tires, which came out to be 29.29 miles per hour. We also test drive to see if we do make it to this speed, and we did make it. Here's the video. Yeah, so our go-kart did reach 30 miles per hour. Yeah. Braking and steering system. Since we had a low budget, we used the band braking system, which is one of the cheapest one. It uses a metal band to constrict around the outside of the brake drum when the brake is pressed over here. And as you can see in this video, it shows how the braking system is working. That's the brake pedal, which is connected with the rod. It uses the band right here. And you could see these features as well. For the steering system, we use spindles. The steering connect to the axle, so right here, and the tie rod, which is connected between the pitman and the spindles, and the pitman arm, which is located at the end of the steering shaft.
So for our battery, we decided to go with a expert power 12 volt 9 amp hour lead battery, and with a push button switch to turn off and on the headlights. And if you can see our diagram, circuit diagram on the top right, we have our solar panel directly connected to the battery. That's due to the fact that there is a built-in circuit board to prevent the battery from discharging back to the solar panel, and it prevents it from overcharging the battery. So for the solar panel, as Chunky mentioned earlier, we use the TP Solar 20 watt monocrystalline panel, and produces 15 volts at 1.3 amps. And in the top right corner, we have headlights that were donated to us by a group member's family member for us. And the solar panel is there to maintain the charged battery for the headlights. And the headlights run about 40 watts each. And this is our assembly process. In this first picture, you can see that we're trying to figure out how we're gonna mount everything, where we're gonna put everything. And the second picture is me, Steven, and Amir cutting wood to attach the solar panel to. The third picture is Emmanuel and Amir mounting the piece of wood that was cut. And we decided to angle it due to the fact that so it directly hits the sun better, and it could charge the battery properly. And in the top right corner is how everything's mounted together. And then the bottom picture is Amir and Chunky zip tying all the wiring together to make it look nice. So this is our final product right here in this top right picture with Amir. And our gas-powered go-kart is working with solar power headlights. The cost was around $500 for everything. And to conclude that, based on all our calculations, we were able to make the go-kart drive between 25 and 30 miles an hour. And here's a video of it.
Thank you guys.